Yes, students, today's topic is refraction of light and refraction through a glass slab. So first of all, what is refraction of light? So by refraction of light, we understand the deviation of a light ray from its straight line path. Simply, we say reflection is bouncing back of the light into the same medium after striking a surface which is polished or maybe rough, and refraction is deviation of a light ray from its straight line path. Okay. Now, it is not that simple. The first question is, why does it deviate? It deviates because when it moves from one transparent medium to the other transparent medium of different optical density and it is incident obliquely, then only refraction takes place. So refraction is the deviation of light ray from its straight line path when the incident ray is oblique to the surface, that is interface between the two mediums, and the mediums should have different optical density. Now what is optical density, students? Optical density is measured in relation to the speed of light in a particular medium. If in a medium the light travels faster, it is said to be optically rarer, and the medium in which the ray of light travels slow, it is considered to be optically denser. So the two mediums, now you see medium 1, medium 2, medium 1, medium 2, medium 1 and medium 2. So here we have two mediums M1, M2, which are separated by the interface. Right? Now, when we look at this diagram, we see that the incidence is oblique. This is the normal, this is angle of incidence, and you can see it is bending towards the normal. Okay? When it is so, when the ray of light, when traveling from medium 1 to medium 2, bends towards the normal, we say this is denser medium. Okay? That is, it has greater optical density. That is, M1 is optically rarer and this is optically denser. Now we come to this. This is again interface. This is incident ray, angle I, angle R. But now you can see that deviation is away from the normal. When you observe this, you come to know that M1 is optically denser and M2 is optically rare. Okay? Now in this case, we see this is normal and this is incident ray. That is, the incidence is normal, so it follows the same path, so there is no refraction. So if it is like this, then the thing is that incidence is oblique and the two mediums may be rarer and denser. Okay? But if you see that there is a normal and the incidence is oblique, but still there is no deviation, right? Two mediums M1, M2, and the incidence is oblique but no deviation. It means both have same optical density. Okay? Now the children question is that why so? Why in some cases it is bending towards the normal and in other cases it is bending away from the normal? Here I would like to tell you one thing, students, that during refraction, yes, the speed of light is changing, wavelength is changing, but frequency is not changing. Frequency is not changing during refraction. That is the main reason why the refraction takes place. That is, whatever number of rays are entering from one medium, the same should be received at the other medium. Now, speed is changing. Either it is decreasing or it is increasing. Now, just consider if three students are standing here and I say go. If they all move with the same speed, then only they will reach in the same way. तभी सारे इकट्ठे वहाँ पहुँचेंगे तीन के तीन, right, at the same time. But if they are not moving with same speed, then the one who is having less speed will have to follow the shorter path. So now look at this and try to understand. Now this is rarer. यहाँ पर speed of light was greater. The light was moving faster. Here the light is moving slowly, but the frequency should remain same. So the light ray bends towards the normal, follows a shorter path so that the frequency remains same. So here wave speed is more, here wave speed is less, right? But frequency remains same. That is why when rarer to denser, bending towards the normal. Now when coming from denser to rarer, it was slow, but it became fast over here. Then the number of rays coming here will be less and here it will be more if they are, coming with more speed. So now they follow the longer path. So they bend away from the normal. Longer path, more speed, but the number of waves on both ends of the interface remains same. Okay? This is the basic concept behind the bending of the refracted ray either towards the normal or away from the normal. Fine. Now I will be talking about the refraction through a glass slab. Now as you are clear about this, so now we have M1, M2 and then again M1. Okay. So light is coming from medium 1 to medium 2. You can see it is bending towards the normal. And then it is coming from M2 to M1. Now it is bending away from the normal. Why? Because these two mediums are now rarer mediums. Their optical density is less and M2 is optically denser medium. So rarer to denser, bending towards the normal. Denser to rarer, bending away from the normal. Is this clear? So now what happens is, if there would have been no glass slab, this ray, incident ray, would have followed this path. But due to the presence of the slab, it first deviated towards the normal from this interface AB. Then it deviated away from the normal from the interface CD. So here you also have to keep one thing in mind, that refraction is a surface phenomenon. Okay? Refraction only takes place at the interface where there is separation of the two media. Okay? So now this is angle of incidence and this is angle of refraction and this is angle of emergence. Incident ray, this is incident ray, then this is refracted ray and then this is emergent ray. Okay? Now you see M1 to M2 deviated by the angle towards the normal. M2 to M1 deviated by an angle away from the normal. Now this angle will be equal to this angle. Because jitna it deviated towards the normal, same amount it deviated away from the normal. Now if there would have been no glass slab, right, then it would have gone that side. But due to the refraction, because of the glass slab, now it is following this path. We can say P, Q, R, S. So now this perpendicular distance, okay, perpendicular distance between the emergent ray and the incident ray produced or extended is defined as lateral shift or lateral displacement. Lateral shift or lateral displacements. Now on what factors does this lateral shift depend? Okay, so factors on which lateral shift depends are: it is directly proportional to angle of incidence. That is, greater the angle of incidence, more will be the displacement. Then it is also directly proportional to the thickness of the slab. Thicker the slab, more will be the displacement. Okay? Is this clear? So that is all about refraction and refraction through a glass slab. I hope you understood. Thank you.